There are a few words that I'm not sure if you still remember. So what does mean by coefficient of friction?
It's like it's multiplied by the normal force to give the friction.
Mm-hmm. So if you have find the part A, can you send me the answer? I'm so generous, okay? I'll help you to draw the diagram. So Harsh, will you stay in Hong Kong or not? Not yet, design.
I don't know.
75 and the 15 degree. Oh, no, sorry. Hmm? No, it's correct. Okay, it's correct. So there is non-motion upwards, and there's also weight downwards. And also there's a friction to the left. So these are all the forces that you can write, draw. Okay. No question, and then take some time to find the. No question, and take some time to find the friction. That means that you need to find the non-motion. Okay. Well, we have less than 1 month. We have 3 weeks more, and then we can start the school. Now, 4 marks question. Well, it is not that easy, or it should be.
Oh, okay. I think I get it.
So for part A, what answer do you get?
Wait. I have to just find the coefficient of friction. Okay.
Do you all get the same answer?
I no for normal reaction.
Mm,
For normal reaction, I got 19.4.
90.4.
Wait. Sorry, not 19.4. Yeah, 19.8. I got 19.8.
Do all of you get the same answer? So first of all, you need to know how to find your norm ratio. So you need to decompose the 75 Newton tension into two components. One is upwards and one is downwards. Sorry, horizontal. And then you know that by considering the vertical forces, the norm ratio of 75 sine 15 degree equal to the weight. So therefore, you can get the norm ratio that oh, so you get the norm ratio is 8.8 Newton. And then if you multiply by the coefficient of friction, then you get the friction to be 7.42 Newton. Any question here? No question.
No question.
Okay, if no question, and then let's go on. So for part B, find the work done by tension to move 6 meters. So you need to decompose the weight to the direction along the displacement. So the answer should be 75 times 6 times cosine 15 degree. So the answer is 435 Joule.
Yeah.
So for part C, okay, I give you 1 or 2 minutes to find the answer. You finish C? How about the others?
I'm thinking.
Yeah. So how do you find the part C? You can use energy approach or using the force. So if you're considering the energy, then that should be the work done on the object 咧435咧 then minus the work done by the friction. Then the work done by the friction is 7.42 times 6, then equal to the kinetic energy of that object. Evan, what's your answer?
Wait. Sorry, I didn't minus the 742 times 6.
At 14.0 meters per second.
14.0.
14.0. Do all of you get the same answer?
Yeah.
I just calculate the thing that you. Yeah.
Okay, 14.0. If no question, then let's go on to question 17. Okay. So have a look at question 17 now. Finish?
Wait, so what's the rate of working? Is it like joules per second?
Rate of working.
Second means power, right?
Your rate of working, that means power.
Okay, so joules per second. Okay.
Finish?
I just don't know what to do after finding like the trust, like the new trust.
You don't know what to after finding the.
Like the new, like the force outputted by the engine.
Uh-huh. So let me write down some steps. So if travel at 20 meters per second with a constant resistive force 600. So if the rate of working of the car is suddenly increased and initial acceleration is 0.5, that means that you can find the initial net force. So the net force should be 1200 times 0.5, okay, m times a. So you get 600 Newton. So what if you consider the three-point diagram? There is a forward driving force. Let me label it as F, okay? And then there is also resistive force, that's 600 backwards. So you know the net force is 600. That means that F minus 600 is equal to 600. Then you can get that the driving force is 1200. So if you know right now, if you know the driving force, then the rate of working, that is the power. Then power can be written as F times V. So that is 1200 times 20. That's 24000 watts. Any question here? No question. How about part? Ah, eh? Ah, I missed the part A. Is it? So if it is traveling at constant speed, then that means the driving force equal to the friction. Then the power is just 600 times 20, 12000. No question. Then can you find the part C?
So what's the speed you got?
What is the
I
speed?
got 10,
So how about
10.8.
so how
I
about
got 10.82.
Yeah, I got 10.8.
This chapter is so easy.
yeah. So and then so let's go on now. No question? And then let's go on now. So let's talk about the next question. I think it's still quite easy. So you may have a look at this. In terms of collision, the momentum always conserved. So we haven't defined what is momentum. So momentum, you know that it is momentum. We use a symbol PR. It is equal to the mass times the velocity. And impulse, we use a symbol I or you use a symbol delta P. That means a change in momentum. So that is mv minus mu. And it is also equal to force, the net force times the change in time. Okay. Then here is for the two particle collisions. Then here is the principle of conservation of momentum. Okay. No question, yeah?
Yeah, no question.
No question, then let's go on now. So you may have a look at some of the question. This one should be quite easy, is it? So, but right now the momentum is 2D. So it has the unit vector I and j.
Yeah.
So impulse is a change in momentum. That means this one equal to mass 0.2 final velocity then minus the mass times the initial velocity. And then you can see how can we get the answer. And let's go on. You may have a look at these two questions and then these three questions, and then we do exercise, okay? In this chapter, in this session. No question?
No question.
No question, then let's go on. So let's do some of the questions. Let's say question 13 and 14. So when t so when t equals 3, it receive an impulse.
Okay, so we can start now. So yesterday I completed.
So so in t equals 3, it receive an impulse. Then what we can do, so we know the initial, so you know the formula is mv minus mu equal to the impulse. I'll draw the vector sign here because they are vectors. It is not one-dimensional now. So and then m times v. So what is the v at t to 3? Oh, sorry. What is the velocity at t to 3? It is, you just substitute in t to 3, okay? So you get 6i plus 12j. Then that equal to the impulse. And the impulse is 2i plus 2j. Okay.
Okay.
So then you get the velocity to be 14i plus 20j. Then for question 14, a ball of mass 2 kg initially moving with the velocity this one, receive an impulse. Find the okay. So the main point is to find the angle through which the ball is deflected. But let's see how we can get this answer. Let's see how we can get the velocity first. So impulse is 2j. That equal to the mass times the final velocity minus mass times the initial velocity. So I think you get the velocity to be to be I. No, sorry, should be I minus my I plus 2j.
Yeah.
There's no question, and then we can go on.
What about the angle?
Yeah. Well, if you draw the diagram, I plus j is somewhere towards here. And then that means it's 1 and 1, okay? I plus 2j is somewhere here. So that means the angle is this angle. So can you find this angle?
$18.4.
18.4.
Yeah.
Okay. That you use arctangent, okay? Then arctangent 2 minus arctangent 1. If in terms of degree there, and then you can get the answer to be 18.4 degree. Okay. No question, then let's go on to the next session. So this is about although we have learned it in physics also about the coefficient of restitution, but we didn't explicitly need to use this concept in physics, the GC physics exam. But let's see how we define this coefficient. So the coefficient of restitution. This part is very
Wait, sir, can you wait for 2 minutes?
mhm.
Yeah, 2 minutes, please. Okay, we can continue.
So before the collision, they have the velocity u1 and u2. And after the collision, they have the velocity v1 and v2. So, and then this is how we define the coefficient of restitution. And then the value of E there should be in between 1 and 0 and 1. If no question, then let's have a look at the following. So may you try to apply these formulas to find the coefficient of restitutions in these 3 cases. All of you get the answer.
Yeah.
So if you have, so you can check the answer here, okay? Don't forget the minus sign here. You can ignore its proof, okay? But you can check the answer here. So for the first one, it's quite easy, okay? So you just substitute in the values. So let's consider A to be 1 and B to be 2. So x minus 0. Sorry. You need to use the final after coefficient 2 minus 0 divided by 0 minus 8. Sorry. A 0 minus 2 and divided by x minus 0. For this one, similarly, 4 minus 5 and 6 minus 3. Okay. For the last one, you need to be in mind that you need to define one direction to be positive. So if you define the right position to be positive, and then in the denominator, it should be 11 minus negative 7. In the numerator, it should be negative 6 minus positive 3. No question? If no question, then let's go on. No question?
No question.
Then let's go on to the following. You may have a look at this exam, maybe this example. Haha. It seems it's very complicated. If no question, then let's go on to talk about. If really no question, then let's go on.
Wait, I'm reading through it. Okay, no question.
Then let's go on. So let's do the question together. So let's have a look at question 8, 9, and 10. So for question 8, it's better for you to draw a diagram. Two particles, mass m and km. Okay. Placed on same smooth horizontal table, a plane. Particle A is made on the plane with the speed u, collide directly with B, okay, which is at rest. After the collision, then ball B has the speed 3/10 u. So, and then you don't know the velocity of this one. So let's say this has a velocity v. So and then for part A, you need to find in terms of the u, find the speed of A after collision. So what you do is using the conservation of momentum. So m1u1 plus m2u2 equal to m1v1 plus m2v2. Then you simplify this equation, okay?
With
So then you get the velocity to be 1 minus k dk over 10.
yeah,
I think this should not be difficult. Then
not difficult.
after you find using the Newton's law of restitution. So what does it mean for this? That means the symbol E, okay? So you know E should be within the value of 1 and 0. So then let's see how we can get this. So if you want to show the inequality, of course you should have the inequality at first. So the inequality, you only get this inequality right now, okay? So you just substitute in the value of E and then try to see to solve it. So let's solve the E, okay? So it's negative and then U minus 0 and then V, okay? Minus this one. So and then try to simplify this. In the numerator, you get 7. Of course, the U can be cancelled out in the equation. So then you can get 3k over 10 plus, minus 7 over 10. That is the value of E. And then you use the inequality. I thought I get something wrong here, but turned out my answer is correct.
Okay.
So and then if it's okay, then let's have a look at question 9. Question 9. So same you need to draw the graph first, okay? M and 3M. A is moving the speed 2u. Moving, it has a speed u, okay, in the same direction. After the collision, B has a speed ku, and then you don't know the speed of A. Okay, let's write it as a symbol V. So for part A, you want to find this speed. So obviously, you still apply the conservation of momentum. And then I think it's not difficult to get the answer. Okay? The question are so similar, okay? But let me write down all the steps without explaining the concept behind it. V the V okay.
Okay.
So if no question, then let's go on to question 10. Are you doing the questions? Everyone is so silent.
Yeah.
For question 10, and then let's draw the diagram again.
Can we try first? Can we try question 10?
Okay. I'll give you 5 minutes, okay? So let me have a look at the. So we finish this chapter next time, and then I'll give you a question. Eh? Oh, we're so slow actually. This one? Yeah, this one. Question 10.
How should you see?
How to do C?
Like how to show?
You show that they are all positive and all negative, then that's it.
Oh, I know.
Finish.
Yeah.
If finish that, then let's see how to do it together. So for part A, that was 6 marks. No, impossible lah. So then directly, it's always better for you to draw the diagram first. So for part A, how to show that the speed of Q after collision is this one. This one is really a tough question actually. So PQ.
Is it?
So you don't know the final velocity of these two actually. So what
Like a simultaneous equation.
and you need to solve the simultaneous equations. Yeah. So first of all, let's write down the conservation of momentum. Okay, let's simplify a little bit by cancel out the mass n. So you get the first equation, and then another equation is from the E. So you get the second equation. So what you want to find is you want to find the V2. Okay, you want to find the V2. So and then how to find the V2? Guess what? Equation 1 and equation 2. So you add these two equations together.
Wait. E equals to minus V1 minus V2, right?
Oh yeah.
Mhm.
Then I change it to a plus sign.
Okay.
So it's so easy to get wrong here. Okay. I'll just give you a trick here.
Yes.
Then you can show the answer already. But it's still fine here because it asks you to show the answer. If you can't show it, that means you get something wrong. So that is for part A. So for part B, obviously you use the equation 1 or equation 2 to get the speed V1. So I would like to use the second equation, of course. It's easier, I see. So V1 will equal to V2 minus 2EU.
Mm.
Is it? Is the answer like this? Oh, no, so sorry.
No.
5 minus VE over 2 times U. Is it?
Yes.
Okay, and
Yeah.
then for part C, let's show the direction of the motion of P unchanged during the collision. So initially, that is for U, okay, you can let it to be positive. So what you need to show is show that V1 is greater than 0, or V1 is positive. That's it. So how can you show it? So you're starting from the definition of E. So if negative 3E, then you get it should be negative 3 and between 0 and negative 3, okay? And 5 plus 5 minus 3E, that is,
Wait, aren't you timesing? Like multiplying?
yeah, multiple negative 3 on both sides.
Huh?
Actually, I do one more step already. So let me write. So how should you do it? You multiple a negative value and then the inequality sign should be changed. 0 times negative is still 0. Okay?
No, I mean like you times -3 in all things, right?
Yeah, on both sides.
The 0 times -3, isn't it?
0.
Oh, never mind, never mind.
So you know what, the U so 5 minus 3 E divided by 2 is a positive number. So therefore, V1 is positive. But
Wait, can I just substitute like E equals to 1 into the equation?
no, because you need to show the range. I said,
Then substitute 1 and 0.
Mhm.
Can you?
Don't be that lazy lah. I'm not
No,
sure.
because I don't know how to do this. Wait.
Um,
It's okay. It's okay.
So for part D, given that the magnitude of the impulse of P on Q, okay, I need to clear the screen soon later. For part D, given that the impulse of P on Q, that means the change in momentum of Q. So Q has a velocity V. The impulse of Q is 2mu. That is 3m times v2 minus 3m times 2u. 2u. Okay.
Mm.
V2 is this one. Then I think you can solve it. So E should be 1/3.
咁快嘅黐線。
No. Yes. Okay.
Yeah, it's correct. It's correct.
Save the screen, okay? And then, so that's the end for today's lesson. Okay? And then, from next week, we go on to talk about the next topic. And then we hope we can finish all the topics before the start of the school, okay? And then, so see you next week, lah. Bye-bye.
Mm.
Bye.
Bye-bye. Bye-bye.